So good morning everyone. In today's lecture we are going to see the another data structure which is called as queues. In the past lecture we have seen stacks and tried to operate on that using a infix to postfix conversion. So queues is also another data structure which is unlike stack deals with two ends. As we have seen in earlier lecture, the stack is having only one end to insert the element, and from the same end we are going to uh, delete the element, that is push and pop the element from same end. Whereas queues is a little different data structure in analogy, and that's what we are going to see in today's lecture. Queue, which is a very known thing for us. In many cases, we are facing these queues, maybe in a cinema ticket line, maybe in a railway reservation line, maybe in a fees counter. There are many, or a billing counter. There are many places where we need to follow a queue, maybe a airport line. So this is a well-known thing for us. No matter we follow it or not, but yes, we come across that many a times. So that same analogy is taken in this particular data structure, which is a linear data structure in which the first element is inserted from one end, which is called as a rear, and the removal of existing element takes place from the other end, called as front. Means it's a again an abstract data type. Means particularly queue is not directly implemented anywhere, but the concept of queue is told, and we are being told that how to operate on that. And depending on the application, this data structure will be used as per our convenience and as per the need of program. That is called as abstract data type. So when I talk about a queue, what we had in case of a stack, we had a kind of array in this, and we were just inserting the elements from this position one by one, and we were popping the elements from the same position one by one. Top was the pointer which was controlling both of them. Okay, so this is what we have seen. So stack is a data structure with one end, whereas queue is a data structure from with two ends, where from one end we are going to insert the element, and from another end we are going to let the elements exit or delete the element. So it's a simple analogy of queue which we are right now using. Just I'm giving you few examples, like here is the queue of people on a counter, and one by one they are getting served. So this is a first person who is standing in front. Okay, and this is the last person who is standing at the rarest position, that is the last position. So the queue will proceed in this way. This is the first member who is going to exit first, then this man will become the first element, then this man, once he exits, the other man will become the first element, and so on. Okay, but if someone want to enter, he will have to stand behind this lady. Okay, that means if someone is getting added to the queue, they are getting added from the rear end, from the rear side. And if someone want to exit the queue, they'll have to exit it from the front. Okay, so that's what the analogy we are following in the queue. Or here the other analogy which is given, where the cars are this way arranged, where we have the first car. Unless and until this exits, we cannot let the next car exit. Okay, once this exits the queue, this will become the first element in the queue. When this exits, this becomes the first element in the queue. Similarly, what we can now formalize it as first in, first out. In stack, what we had, last in, first out. The element which is put last will be taken out first in stack. Whereas in queue, the element which will come in first will be taken out first. Okay, so first in, first out, or last in, last out. The element which will be put last will be exiting the queue at the last. Okay, So this is a simple analogy, or this we have also taken. The data will be inputted from this end and will be exited from this end. Okay, so one by one we are going to. So this is a simple analogy of queue. We'll try to understand how it will work. Definitely, right now we have implemented stack also using an array, and we are going to implement what you say, the queue also using an array. Okay, so we'll try to understand how that will be implemented. Let us see it. There are the operations which we are going to perform on a queue are inserting an element in a queue or adding an item in a queue. That is called as adding an element in queue and so both are an item to the queue. Along with that, few supporting functions also we are going to see. Like we'll have to check whether the queue is full or not. If it is full, then no further items can be added. If it is an empty, no items can be deleted. And a peek function which gets the element at the front of the queue without removing it. It will just tell you who is at the front, which element is at the front. Okay, that's the peek operation. These are the three operations which we are going to supporting operations which we are going to perform on a queue. Let us see how this analogy works one by one, how it works. So we have a queue. It's an array. Okay, it's an array. Initially, when the queue is at the initial state, that means it is just created and is not pointing anywhere. Is not pointing anywhere. So at that time, if you remember how we are initializing top, okay, top and rear both will be initialized by initialized to -1. Why? Because when we will add, okay, sorry, when we will add one element in a queue, that time it will be the first element as well as it will be the last element in the queue. Okay, so when we'll add the first element, it will be the first as well as last element in the queue. Okay, so let us say that this is a queue and initialization will be front. F is front, the end from which we are going to delete the element, remove the element. And R is rear, the end from which we are going to add the element, insert the element. Okay, but at the initial stage, both will be pointing to -1, will not be pointing to anywhere in the queue. Fine. So this will be the initial position. What will be next position? Let us say that we are adding one element in the queue. First element in the queue. Let us say that we have added 10. We have added 10 in the queue. So which is the first element in the queue? 10. Which is the last element in the queue? 10. So this will be pointed by F and the same will be pointed by R. Okay, that means what I am doing, I am just incrementing front by 1 and rear by 1 in the first insertion. Okay, I'm still sticking to that. So as an array, it will be starting from 0 index. So F becomes 0 after the first insertion and R also becomes 0. Okay, so first case is in initial case F and R both will be -1. When you add the first element, F will also be added by 1 and R will also be added by 1, and both will point to the same element. Fine. Now what is the next case? When we'll add the second element, what we have, F is equal to 0, R is equal to 0. With this information and one element inserted in this, F is pointing here. Okay, 10 is the first element of an array. Now R is right now pointing here to the same element where front is pointing, because there is only one element in the queue. Now let us say that we have added 20. We have added 20. Okay, it is the same subscript we are going to have. We have added 20 in the queue. What will happen? That's what I said. We are going to add from the rear side of the queue. Okay, from the rear pointer of the queue. So how we are going to add it? How we are going to add it? We are going to keep front unchanged, because 10 will be the still first element, and you are going to change r to 1. So you are going to make r is equal to r plus 1. Okay, now r will not be pointing to 0 anymore. R will not be pointing to 0 anymore, but it will be pointing to 1. Okay, and we are going to add the element at position. Let us say that, let us name this as q. We are going to add the element at this position. QR is equal to item. Are you getting me? What is QF? QF is the first element. What is QR? Is the last element. Now 10 is the first element of Q, 20 is the last element of Q. Fine. Let us say one more case. Now at this moment we have f is equal to 0, r is equal to 1. Now there are two elements, 10 and 20, at first and second position, or 0th. Okay, sorry. This is the 20 element 20 which is added, and this is the 0th element, first, second, third, and fourth. Now what we are going to do when we want to wish to add one more element? Say, let us say that the element which I want to add is 30. What I am going to do? Am I going to change f? No, we are not going to change f, because we are adding an element. So even if whatever number of elements you add, the first member is going to be the first one. Okay, so f remains unchanged, it remains 0. What we are going to do, we are simply going to increment r. R is 1, it will become 2. So, and what we are going to do, as per this information, q of r is, that is q of 2, will be equal to 30. So r is incremented by 1, r is going to point to this position, and q of r is going to become 30. Okay, with this you can understand that when we are inserting an element, we are incrementing r by 1. The way we are doing in stack, whenever we were pushing one element, we were incrementing top. So likewise, here we are incrementing r. One more element will be added, r will be incremented. One more element will be added, r will be incremented. If this I becomes 40, again I am going to add 1 into r, and r will become 30, and q of r, that is q of 3, will become 40. R will now point to this element. You observe here, we are not making any change in f, because first element remains first element. And if you want to delete an element, the first element will be deleted first. But if you are adding one element, it will be added at the end of Q. That's what we are doing. 10 is added, after that 20, after 20, 30 will be placed, after 30, 40 will be placed. It's not like we can insert anything in between. That's an analogy of Q. We are going to stand one by one. No one can come and take a position in between. The element need to be pushed or put at the end always. That's what we are expecting. Fine. So this way we are going to one more element we'll add and we'll finish it, finish the insertion, and then we'll see the deletion of it. So f is right now 0 for us, r is 3 for us. Let us say that we wish to add an element I is equal to 50. Already we have inserted 10, 20, 30, 40. We have already inserted. Okay, so f is going to point to the first element only. So q of f is 10, will be always the 0th element in this case. Okay, and rear is right now pointing to 3, but when I want to insert one element, I am going to make r as 4. Rear will be pointing to this element, and q of r will be initialized to 50. Q of r will be initialized to 50. So this will be the value of r. This way we can insert the element. Now if I further wish to insert an element, what will be the case? R will exceed size. R will exceed size. Okay, and if r is exceeding size, r is greater than size, we will not be able to insert an element, because that will be a condition of q full. That will be a condition of q full. Q will be full and we won't be able to add any element in that. Okay, are you understanding me? Now when I want to delete an element, what I am going to do? Okay, when I want to delete an element, now as I said earlier, an element will be inserted from one end, that is rear, and will be deleted from one end, another end, that is front. So if I see this will be your rear end, from where we are inputting the elements one by one, and this will be your front end, from which the elements are going to exit. Okay, everywhere. This is your front end, and from rear end we are inserting the elements. Okay, so it is inserted at this position. Fine. Now if I want to delete an element, what can I do? Okay, what will I do? So it is right now 0 and this is 4. The elements are inserted here as 10, 20. There are 5 all elements. The queue is already full. Q is already made full, and R is pointing to this position. F is pointing to this position. The same diagram I am drawing, which is there. Okay, this is named as Q. This is 0th element, 1, 2, 3, and 4. Now, if I want to delete an element, I can delete it only from the front end. So, which element will be deleted? 10 will be deleted. The element which will be deleted is 10. Okay. So, I can delete from this end. The element is going to exit from this end. So, if I am removing 10 from this, then which will become the first element? This will become the first element. Okay, this will become the first element. So F is going to point here, and position number Q0 will be empty. Position number Q0 will be empty. Right? So what we did here, simply F minus minus. Okay. So we'll first remove Q of F, that is Q of 0, and F plus plus, not F minus minus, I'm sorry, F plus plus. So in this case, we are going to increment F so that it will point to the next element. So first is out, so next becomes the first. He is out, then next becomes the first. If I want to remove further, I'm going to remove this element, 20. So front 30 will become the first element, the front element. So every time we are deleting one element, we are going to increment F. How long we are going to increment F? Till F exceeds the value of R. Till F exceeds the value of R. Because if F exceeds the value of R, in this case, it is going to get positioned here. it is going to get positioned here. That means there are no further elements in the queue. Fine. Till what point we can delete the element? Till f is equal to r. Or means we can very simply say that we can delete the element till we have f less than or equal to r. Am I right? Once f becomes greater than r, that means q is empty. All the elements in the queue are already being removed. Okay, that means we cannot delete any other elements. So this is a queue empty condition. Queue empty condition in case when some elements were present there and they are deleted. Queue empty is the initial condition also when there were no elements inserted. So this condition, that conditions are different, right? So in this case, what we have seen, first thing, when we can simply write here, I'll write here for you. What is the initial condition? Initial condition is f equal to r equal to -1. Okay, there are no elements inserted till that. When we enter the first element, what we are going to do? F plus plus, and also we are going to make r plus plus. Both will be incremented so that both are going to point to the 0th element. Okay, that is the first element insertion. Now inserting second onwards, second element onwards, what we are going to do? We are simply going to increment rear. How long? Till rear become greater than size. So after second element insertion, we are going to change only r. F will be remaining same insertion. When we delete the element, at that time f will be incremented. How long? Till f becomes f is less than or equal to r. Till that point I can go on deleting the elements. Okay, so initial f and r both pointing to -1. First element insertion, both will be incremented by 1 so that both will point to the 0th element. The first element and last element will be same. From second onwards, the first element and last element will be different. So we are going to only increment r by 1 second element onwards for insertion, and for deletion we are going to add 1 to f. We are going to shift the pointer of front to the next element in the queue. So in this case, if 10 is removed, this is going to be the first element. When 20 is removed, this is going to be the first element. When 30 is removed, this is going to be the first element. Okay, so f is going to get incremented by 1. How long? Till we get f pointing to the element which is bigger than rear. So if f is greater than rear, at that time q became empty. But when f is equal to r, I am saying, or when I say f is greater than r, this is a condition when all the elements in the queue are removed. Whereas that is a queue empty condition. Queue is empty after removal of all elements. This is also a queue empty condition. The first initial condition is also a queue empty condition, but at that time no elements were added in the queue, right? So this way the queue is operated on. If you have not understood this, please scroll back and listen to all these operations which we performed on this queue. It will be clear. So I hope this is understood. So what we are actually doing here, see, that's what we have written in the algorithmic form. That is NQ operation. When we want to add some element, check if the queue is full. When queue will be full, when queue R and F will be pointing to the last element, or R is greater than size. Okay. So if queue is not full, if queue is full, produce a overflow error, and if queue is not full, increment rear pointer. Increment a rear pointer so that it will point to the next empty place in the queue. Next empty place in the queue. Add a data element to the queue location. Which location? Where rear is pointing. Okay. Add data element, the newly coming data element to the queue location where the rear pointer is pointing. Where rear is pointing? To the next element of the previously last element. Okay, and return success. It is coded in this form. We are going to enter a parameter as data, and if it is full, we are going to return 0 so that no further elements can be inserted. If it is not, rear is incremented by 1. Q rear is equal to data, and return 1. Return 1 means it is a successful execution of a program. Okay, so what we are doing in insertion, simply insertion. There are further intricacies are there. One by one we are going to check whether the element is first or not. So right now, when I want to insert an element, in general case, even it is the first element, we are actually incrementing R, isn't it? Even if it is the first element, we are incrementing R. Okay, similarly, so if it is a insert operation we are performing, we are going to increment rear by 1. That only you remember. And reverse will be the case when we delete some element from a queue. So a dequeue operation, which is a removal of an element, from the queue. So for that purpose, we'll have to first check whether the queue is empty or not. Okay. If queue is not empty, then we cannot delete any element. We are going to print an error. But if queue is not empty, access the data where front is pointing. Access the data where front is pointing. Front is pointing to whom? Front is pointing to the first element of the array. So if I am performing a dequeue operation, that first element need to be removed so that next will become the first. In a normal queue, when we proceed, the first person will get served, he will leave the queue, second will become the next first person. He will leave the queue, the next person will become the first person. Okay, so first you access the data where front is pointing, increment front pointer F++ to point to the next available data element. So we will increment front pointer so that it will point to the next element in the queue and return success. So simple way. DQ is not going to take any arguments, of course. It is going to check whether it is empty or not. If it is empty, return 0. If it is not empty, collect the element in the front of queue in a variable data. Okay, this is the first element. Currently it is at the location, and now we are just incrementing front by 1. So it will point to the next element automatically. That is even though it is not physically removed, but it is no more the first element in the array or in the queue. Okay, next element becomes. So for deletion, a very simple thing we need to just remember: increment F. So again I am repeating, listen to me clearly. Again I am repeating, if it is the first element to be inserted, F and R both will be incremented by 1 so that it will be pointing to the 0th element. So if there is only one element in the queue, F and R both are going to point to the same. Fine. This thing you please remember. It is a different case than a normal insertion. Normal insertion will be for the second, third, or second onwards. But if I am inserting the first element, it will always be the increment of front and rear pointers both. And if I am decrementing, immediately deleting the first element, only element in the queue, F will be incremented and F will exceed rear, and condition will be satisfied. Right? So this is what you need to remember very clearly. Three cases I am repeating continuously. Initial condition, first element of insertion of first element, and insertion of the second element onwards. Okay, these three things are different. In the initial position, front and rear both will be -1. In the as soon as we insert the first element, both F and rear R will be incremented by 1, so that both will point to zeroth element of the queue. That means the only element in the queue, because that will be the first and last element in the queue. Okay, and if it is the second element to be inserted, only rear will be incremented by 1. And in any case, when you perform delete, front will be incremented by 1. We are going to increment it till it exceeds the value of rear. And if it exceeds the value of rear, that means there are no further elements remaining in the queue to be deleted. So these are the two functions which you'll have to remember. As we did in the stack, there was a direct application of stack in conversion of infix to postfix expressions. That we did, but in this case we don't have any direct application. That's why we are not going to take any kind of example for this. But applications of queue are, as the name suggests, it is used whenever we need to manage any group of objects in an order in which first come, first serve is needed, or first one coming in also gets out first while others wait for their turn. If there is a scenario in this case, in such cases this will be used, like as the example which I have given for queue was the print queue. If there is only one printer which is shared by many computers in the office and many people are trying to access that, it will prepare a queue and one by one the jobs will be printed. Okay, it will never happen that one page of first job, one page of the second job. No, it is going to print the entire document of the first computer, then it will be handling the second job of the other computer, then third job, and fourth job, and so on. So print queue. Similarly, serving the request on a single shared resource, that's what the print, like printer, CPU task scheduling, and etc. In real life scenario, call center phone system uses a queues to hold the people calling them in an order. Okay, it will generally, once you are we will be calling, then they'll give you the waiting period also. Your waiting time is 15 minutes, 10 minutes, 2 minutes, 1 minute, like that. So that they'll queue up your yourself and will tell you you are at this number and you will be served after 10 minutes or after 15 minutes. Or handling the interrupts in real-time system. So there may be interrupts, means CPU is busy doing something, and some other jobs are coming in for CPU which may be of higher priority than the current job it is doing. So at that time a queue is maintained. If the job is at higher priority, it will be put first, and if it is of lower priority, it will be first put at the end. So these kind of applications are there. Actually, we are not implementing any of these applications at this level of programming, but this is just to make you people know about these kind of activities are available or not. Okay, so now immediately what you are going to do is you are going to view this lecture, and by 4 o'clock, remember 4 o'clock today, you are going to submit a program which will illustrate the operations of queue. Initialize a queue, with a simple array. Write the function of enqueue, write the function of dequeue, write a small function of display, which will display that array. Okay, with the array only you are going to write the queue. So in the main, you are going to declare a queue array and write 4-5 enqueue functions and 2-3 dequeue functions. And every time after every enqueue and dequeue, you please display your queue one by one. Okay, so exactly how the changes are happening in the queue, that will be made visible. This is your job to try a program. Do not copy and paste, it is of no value for me. Okay, and even is going to be of no value for you, but it may cause a loss to you. Instead, try to write a program, maybe a smaller one, but try to write a program by your own. Fine. So this is what today's assignment. Thank you very much.